There's another set of designs called adaptive model designs. This will start with a cohort of size n. So it can be 3, 10, 20, however large is deemed necessary in your first time period. You need to have sufficient n in that first time period to run a model. So obviously one person wouldn't be sufficient. I would argue that 3 probably isn't as well, but maybe here 5 or 6. And then they fit a model. And they will fit a model predicting the next set of outcomes based at a slightly higher dose. Then they randomize more people. Then they enroll more people at dose level 2. After time period 2 has stopped, they will stop and fit a model, again predicting the appropriate dose level 3. And they'll enroll a number of participants again. And in this case, we had 1 bad outcome and 5 good outcomes. So this was apparently an acceptable threshold. So they continued on with another model to dose 4, where there were 2 poor outcomes and 4 good outcomes. They ran another model, which then indicated that they should stop escalating the dose. So this is going to use much more information, and it's going to use a sort of higher order determination on how to escalate the dose or the likelihood of success if you escalate the dose. But it is also more complex, as indicated by the little graph and the longer delay in between time periods. Adaptive models can take a little bit more time to enroll. But we have the same questions here. What is the MAD, the MTD, and the recommended phase 2 dose? And how many time periods would it take to get to each of those based on the adaptive model design?